Good day, everyone. We are now going to start our lesson. Now, first of all, we will discuss with our essay question, question number 10. Please get ready with your question and your answer. Okay, this is the question number 10 that you have done. Now, the table shows the ions in unpolluted river, which is in river A. See here, the keywords here, unpolluted. Unpolluted, these ions are present inside them. Now, this is the concentration. A factory accidentally flowed the wastewater industry into River A. That means now polluted. Besides the ions stated in this table, suggest one cation and one anion in the wastewater that caused the river to be cloudy. Now, keywords here, cloudy. And you are going to explain your answer, explain, and also write the ionic equation. So what can be formed? What can be the cation that is poured into the river and make it to be cloudy? Here, you might have to interpret what is the meaning of cloudy here. The cloudy here means it forms precipitate. When it forms precipitate, meaning it is forming an insoluble salt. So from these ions, which one can form an insoluble salt? Okay, now, which one can form an insoluble salt? Anyone? Can you please give me an idea?
Silver?
Which
Silver
ion?
chloride.
Sorry?
Silver?
Silver.
Silver ion? No, this one here, this one. The type of ions here that can form this precipitate. It will be number one, the sulfate ion, okay? Number two, the chloride ion, okay? Now, the calcium ion can also form a precipitate, okay? Why? Because we learned about the calcium carbonate. All carbonate are insoluble except the group 1 carbonate or the ammonium carbonate. So the magnesium ion also can form a precipitate, but not the sodium ion and the potassium ion. Now, the keywords of the question, it wants us to identify cation, okay, and one anion, meaning the cation must be combined with this sulfate ion or the chloride ion to give you a precipitate. So what cation can it be? Any suggestion?
Silver.
I heard someone telling something.
Silver, teacher.
Sorry?
Silver.
Silver. No silver. It's silver ion. So it would be
Silver ion.
Ag positive. Other than Ag positive, Adeline, can you give another example of the cation that can form a precipitate with either the sulfate ion or the chloride ion?
Barium.
Okay, the barium ion. Ba2 positive. Now, for those who have problem to identify these ions, actually, what is the concept that they are testing you? The concept that they are testing you here will be the formation of insoluble salt. Okay. Now, talk about the sulfate salt. We know that all the sulfate salt are soluble except the PCB for the sulfate salt. We have already mentioned the barium ion. Okay. So another two types of ion can be the lead-2 ion or the calcium ion. But the calcium ion is already here, so we don't mention about that. Okay. Now goes for the now we go for this the chloride ion. All the chloride salt are soluble except the PAH. So the P is already here. The A is already mentioned, and you can actually put the mercury 1 ion. Okay, but then we seldom talk about that. That's why we are sticking to these three types of ion. You put one is enough because they want you to suggest one. Now, another anion. So your answer, you are going to put anion. So what is your suggestion? What is the ion that can combine with the calcium ion or the magnesium ion to give you an insoluble salt? You have only one answer, which is the carbonate ion, as what I mentioned just now. Now you don't go for the sodium ion and the potassium ion. Why? Because they are all going to form a soluble salt when there is a sodium ion or the potassium ion. So with this, you are actually already obtained your marks, which is for which is 1 mark each here. And now we are going to explain why do you choose silver ion, let's say, for the cation. So what is the reason? Why do you choose silver ion? What will be the silver ion do? You are going to say that the silver ion will react with wait, one friend coming in. Okay, the silver ion will react with the chloride ion to form silver chloride, which is an insoluble salt. Okay, so this is your explanation, and from here you can actually write your ionic equation. What will be your ionic equation? The silver ion combined with the chloride ion, giving you the silver chloride. Okay, so this is for the cation, for the explanation for the choice of cation. So for the explanation for the choice of anion, what are you going to tell? You can say that the calcium ion will react with the carbonate ion to form an insoluble salt, which is the calcium carbonate. Or you can put the magnesium ion react with the carbonate ion to form an insoluble salt, which is the magnesium carbonate. Then you are going to write your ionic equation. Okay. Now, how do you get your marks? I'm going to tell you. Point 1, you state one cation correctly. Point 2, you state one anion correctly. Point 3, explanation for the cation that reacts with one of the anions to produce insoluble salt. Point 4, it is the ionic equation. Point 5 that I don't write down, it will be the reaction between the calcium ion or the magnesium ion with the carbonate ion to give you insoluble salt. And the last point will be writing the ionic equation for the formation of calcium carbonate or the magnesium carbonate. Okay, I hope you are okay until here. Now, next part, we are now going to move on to part 2. Based on the table 10, identify 2 ions. Yes?
Teacher, the one with the anion part of the explanation, it can be magnesium and calcium. So I have to mention both or just
You can
one
mention
really?
either one. You can mention either one. Okay, now next part. Identify 2 ions. Can you see? 2 in the river water that can cause cleaning clothes using soap to produce scum. Now, what are they talking about? Actually, they want to relate to the presence of hard water. Do you still remember our hard water? Okay, I hope you can still remember. Hard water means water which contains relatively high concentration of calcium ion or the magnesium ion. Therefore, this is your answer. The 2 ions mentioned here will be number 1, your point, calcium ion, point 1, magnesium ion, point 2. Okay, next part. By using a named chemical substance. Can you see the word named chemical substance? Meaning you are going to name the substance. You are going to describe a laboratory experiment how one of the ion can be eliminated from river water. That means you want to remove one of these ions. You want to remove the calcium ion or the magnesium ion from the water. and you are going to mention about the type of reaction and also the product form. Okay, now what is the type of reaction actually? Actually, they want you to talk about the formation of insoluble salt. Okay, and our reaction will be the double decomposition reaction. Okay, now you want to remove the calcium ion, let's say. I am using the whiteboard now. Okay, just now in our answer, we have already mentioned the ions will be the calcium ion and also the magnesium ion. Okay, so now our next question, we want to remove either one of these. Let's say I want to remove the calcium ion. Okay, so I am going to have it to undergo the double decomposition reaction. I want it to undergo double decomposition reaction. So I must have two substances. What are the substances? Number one, I have to have a calcium, a solution with the calcium ion. Okay. For example, with this river, the river water is there. The river water is there. So actually, I'm putting the river water with one of the solution. Okay, now I want to remove this calcium ion, so I am going to get help of the potassium carbonate, let's say. Okay, now when I get help from the potassium carbonate, I am going to get calcium carbonate, agree, and also another solution. I hope you agree with me until here. If you can understand, you please show me a light. Can you understand? Okay. Okay, most of you can understand, Okay, what about others? Yanjun, Kachun, Ridwan? Okay, can, you know what is happening, Samyu and GK? Can you?
Teacher,
Yes.
why we add potassium carbonate with river water, sir?
Okay, what is the reason of adding the potassium carbonate? If we don't want the potassium carbonate, actually, we can use the sodium carbonate. Sorry? Okay, actually, we can also use the sodium carbonate if we don't want to use the potassium carbonate. The reason is we want to actually have this to occur. In our river, we have calcium ion. When we use the carbonate solution, which is soluble, we are going to have carbonate ion, and we are going to have calcium carbonate to be produced. Okay? Can follow, That is the
And
reason. If we are using the sodium carbonate, we are still going to have this to occur. Okay? Because the potassium ion and the sodium ion here, they are actually the spectator ion. What we want is the carbonate ion. If I want to eliminate the magnesium ion, it is still like this. Because the magnesium ion will also react with the carbonate ion to give you the magnesium carbonate. That is the reason. Okay, so here, according to our question here, they want us to include in our answer the type of reaction and also the product form. So the type of reaction, double decomposition reaction, the product form will be the calcium carbonate or the magnesium carbonate. The named substance, it will be the potassium carbonate solution or the sodium carbonate solution. So easily you have already get 3 marks. Okay, chemical substance 1 mark, reaction 1 mark, product form 1 mark, 3 marks. Now another 7 marks. How do we get the 7 marks? So we are actually describing about the double decomposition reaction, where step 1. Okay, who can contribute your answer for step 1? I think I would like to call you. Step 1, Amisha. Amisha?
Measure and pour 50 centimeter cube, 0.5 mole per decimeter cube of potassium carbonate into a beaker.
Okay, now our friend said measure and pour 50 centimeter cube, 0.5 mole per decimeter cube of potassium carbonate solution into a beaker. That is correct. Okay, now next sentence. What are you going to do? We have already mentioned about the potassium carbonate. So now we are going to mention something about the river water. Now in our question previously, when we said we want to have double decomposition reaction to occur, we are actually going to measure and pour the, let's say, the calcium nitrate solution. We mentioned the volume and concentration, which is 50 centimeter cube, 0.5 mole per decimeter cube of calcium nitrate solution into another beaker. But in this case, we are not going to tell about the calcium nitrate solution. We are going to substitute this by using the word river water. I repeat now. Step 1 is as what we mentioned just now. Measure and pour 50 centimeter cube, 0.5 mole per decimeter cube of potassium carbonate solution into a beaker. Now, second step, we are going to say that we are going to measure and pour 50 centimeter cube of river water into another beaker. Okay, now what is the next step? We would like to hear from Catherine. We have two solutions already. So what to do next? We have already get two solutions. Mix. What mix to what?
Pour the river water into the potassium carbonate.
Okay, correct. We are going to pour the river water into the potassium carbonate solution, or pour the river water into the beaker which contains potassium carbonate solution. Okay, what you are obtaining will be like this, and this will be the precipitate. Okay, now whenever you add things together, what will be the next step? I would like to hear from Jun.
Stir and filter the mixture.
Yes, step 4 will be always stirring. So stir the mixture. Now, step 5. Can I hear from Dakshish?
Filter the mixture.
Filter the mixture, correct. Step 6. Can I hear from Yanjun?
Dry the crystal by pressing it between piece of filter paper.
Okay, our friend said she's using the word crystal. Okay, now we know that this is an insoluble salt. So can we use the word crystal? Yes or no? Dylan, can we use the word crystal?
Can.
Cannot. I love you. The answer is cannot. Now, crystal is for soluble salt. I repeat now. When we are talking about insoluble salt, we are going to use the word precipitate. Okay? Now, one more step that is not mentioned is we cannot straight away dry the precipitate by using the pieces, by pressing it between pieces of filter papers. Before we dry it, what should we do first? Shall we hear from Satya? Satya, are you there?
Yes, sure.
Okay, what should you do before drying it? Step 6. Anyone has idea? Adeline, can you? Step 6. And no SPM for you. No SPM for you all. Nitish, you sure can answer. What is step 6? After you filter, what should you do first? Let's hear from our birthday boy, Avi.
Teacher, pour the solution into an evaporating dish.
Baby, this is precipitate. No need to pour into an evaporating dish. Okay. I think all of you long time didn't see me, so you forget already. Now, after you filter from here, after you filter, this is the precipitate. You write it long, this is the precipitate. Okay. Before you press it dry, what are you going to do is, you are going to rinse with distilled water. You have forgotten this step. So step 6, rinse the precipitate by using distilled water. Then only step 7, press the precipitate in between pieces filter paper to dry it. Okay, I repeat the steps. Step 1, measure and pour 50 centimeter cube, 0.5 mole per decimeter cube of potassium carbonate solution into a beaker. Next, we talk about this, measure and pour 50 centimeter cube of river water into another beaker. Then you mix this together and you are going to stir the mixture. Then you filter. After filter, you wash. Rinse the precipitate or you wash the precipitate using distilled water. Then only you press it dry. Okay? I hope you are well versed with this. Okay, next part. We are now going to the last question, which is part C. Part B. Okay, next part. Now the diagram shows zinc oxide powder added into 2 different acids to produce salt J and salt L. This is the this is the zinc oxide. When added with sulfuric acid, okay, you get salt J. Zinc oxide, when added with hydrochloric acid, you get salt L. Before we continue about salt J and salt L, we are now going to write a balanced chemical equation for these 2 processes. Okay. Now, I hope you get this as your chemical equation. If you have not written, you please write now. Here, from here, when you have zinc oxide added with sulfuric acid, you are going to get actually the zinc sulfate and the hydrogen and the water. Do you agree? Because this is metal oxide. Now, if you have forgotten, you are actually doing this positive, negative, positive, negative. Okay? The positive from the front, take the negative from the back. So you get this. Now, what is actually the salt J? The salt J is actually the zinc sulfate. Now, what is salt L? We are now going to write the equation. You will have ZNO react with hydrochloric acid, giving you the zinc chloride and the water. Balance up the equation now. So the salt L will be actually the zinc chloride solution. Now, next part. Briefly describe a chemical test to verify the N ion that present in J and L. So for salt J, what is the N ion? For salt J, the N ion will be the sulfate ion. And for salt L, the N ion will be actually the chloride ion. Okay? So now we are going to talk about the chemical test for the N ion and cation ion. Okay. Now we are going to continue by using the whiteboard. Now when we want to talk about the test for the N ion, so you please put the title. Please put the title, test for N ion in salt J. What is the N ion? Which is the sulfate ion. Okay, so now what is the first step? Number 1, what should you do? Can I hear from our friend? Who I have not called today? Nitish, you have not answered our question just now.
Sure.
Yes.
Add nitrate, sir.
Add what?
Nitrate solution.
What nitrate solution?
Into salt J.
Hi, are you sure? Okay,
Kinda.
initially, what should you add? What is the first step? You are not going to straight away add nitrate solution. What should you add, Samyu?
Add salt J into a test tube.
Okay, pour salt J. How much?
5 cm cube.
Okay, good. 5 centimeter cube of salt J into a test tube. Okay, then after that, what to do? Next, I want to hear from Yan Xuan. What to add now?
Add barium chloride solution.
Add barium chloride solution. Are you sure you are straight away adding the chloride solution? Or you should add an acid first?
Add acid first.
What type of acid that you want to add?
Sulfuric acid.
Okay, if you are using sulfuric acid, can you see you have a sulfate ion here? Then you cannot add sulfuric acid. So what should you add is actually, you add 2 centimeter cube of hydrochloric acid, followed by 2 centimeter cube of barium chloride solution into the test tube. Okay,
Teacher.
Yes.
Sure. The adding of hydrochloric acid is already shown in the diagram. So if we write, do we still get marks?
Hello. You please make sure which part of the diagram that you are looking at. We are now talking about the salt J, meaning how do we get the salt J? We are actually having in the test tube, we have zinc oxide and you are adding in the H2SO4. Have you added with the HCl? Then from here, what are you going to have? You will have your zinc sulfate and water being formed. Okay, so you have not added with any of the hydrochloric acid yet. Now in your picture, you are actually having two parts. We are now talking about the part on the left hand side. Okay, now I want you to take note about this. Can you see the hydrochloric acid and the barium chloride? When you are using the HCl, when you are using the HCl, it will be always with the barium chloride. If you don't want the barium chloride, you can use the HNO3 with the barium nitrate actually. Okay. Now what is the purpose? The main purpose is we want this barium ion or this barium ion so that when you add in, this barium ion will react with the sulfate ion to give you barium sulfate, which is from your observation here, you should have white precipitate form shows the presence of sulfate ion. I repeat, when you want to talk about the test, number one, you pour the salt solution into the test tube. Then you add in this, then your observation. Okay? Now, for the next part, we are talking about our chloride ion. So the same thing, what will be your title? Your title, you are going to put test for anion in solution or the salt L. Okay, what anion, which is the chloride ion. This is your title. So now what is your first step? Your first step is still pour, measure and pour. Like what we said just now, 5 centimeter cube of salt L. Solution into where? Into a test tube. Okay. Now we know that it is having this. We know that it is having this chloride ion inside there. Therefore, we are using actually the HNO3 and the AgNO3. So your step just now, you have to change. You add 2 centimeter cube of nitric acid followed by 2 centimeter cube of silver nitrate solution into salt L or into solution L. Then what is seen? Again, white precipitate is formed. Why is there white precipitate? It is because of the presence of silver ion and the chloride ion to give you the silver chloride. I hope you can follow until here. Any problem until here? Any problem until here? No,
Sir,
Yes.
sir, I just say add silver nitrate into the salt salt L.
No, cannot. You have to tell you are adding in this acid first. It is helping you to remove the impurities. Whenever you are talking about an ion test, always must start with an acid. If you add with the solution only, it will affect your results. If there is these impurities, your result will be will not be a true result. Okay, Any problem? I hope everyone have already remembered that. Okay. Now, thank you for joining this session.